Chapter 3, current electricity. Yes, theory is over. Now it's time for illustrations and examples. See, one example. Example 3.7. Determine current in each branch. Yes, you are given this circuit and you have to find current flowing from each branch. Okay, yes, it is combination of physics and maths. Okay, see, yes, in your textbook you are given current distribution in each and every branch you are indicated current. Okay, but now if you are not given, then how to assume? See, here it is. I am assuming current. I have, see, in this network you are given two cells, one is and another is this. So I am assuming from positive terminal of this cell I1 current is coming out. Clear? Okay. Now this I1 current from this junction A, apply Kirchhoff's first rule. Current entering any junction is equal to current leaving any junction. So current entering this junction is I1. So what is current leaving? We have two branches. So I am assuming if in this branch current flowing is I, then what is current in this branch? It is I1 minus I2. Clear about this? Again, I1 current enters junction A. I2 and I1 minus I2 leaves this junction A. If you add this two, you will get I1. It is Kirchhoff's first rule. Clear about this? Okay. From point A, yes, here I2 is moving in this direction. Yes or no? Yes. I am also assuming, yes, we have already assumed I1 and I2. From this second cell, from positive terminal of this second cell, I am assuming current I3 is moving in this direction. From positive terminal of this cell, let current I3 is moving in this direction. So now, what happens at point B? What happens at point B? See, at point B, I2 enters, I3 enters. So obviously, current entering is equal to current leaving according to law of conservation of charge. So in this branch, this current leaving is I2 plus I3. Clear about this? It is I2 plus I3. Clear about this? Okay. So yes, it is simple. It is I2 plus I3. Okay. Now see, I2 plus I3, I2 plus I3, I2 plus I3. Now here it is I2 plus I3. Now at this point junction C, what happens? See, if you remember, we have already discussed some circuit. If I assume, okay, from positive terminal current flowing is I1, then in a negative terminal I1 must anchor. Yes or no? So yes, as it is a cell, from its positive terminal I1 current is flowing outside. Then in its negative terminal I1 current must go inside. Okay, so out of this I2 plus I3, if I1 current is flowing in this branch, out of this I2 plus I3, I1 current is flowing in this branch, then what is current flowing in this branch? It is I2 plus I3 minus I1. Clear about this? I2 plus I3 minus I1 in this direction. Okay, now what happens at point B? Point B, I2 plus I3 minus I1 enters, I1 minus I2 enters, add these two current to see, I1 positive, I1 negative, cut, yes or no? I2 negative, I2 positive, cut, yes or no? Yes, then what remains? Only I3. See, again, from positive terminal, we have assumed that current coming outside is I3. If your current distribution is right, you will get here I3. You will get here I3. Clear about this? So yes, in textbook you are given this current distribution. But if you are not given, then how to assume current distribution? So in Kirchhoff's law, when you apply Kirchhoff's law, the most important thing is current distribution. Okay, if you have this type of current distribution, then yes, now you have to apply Kirchhoff's law in any loop. Okay, so yes, you have to write one statement, that is current distribution is as shown in figure. Yes, you know it, as shown in figure. Okay, now we will take a look. See, now we will take a look. See, here you have to find current flowing from each branch. Current flowing from each branch. We have assumed I1, I2 and I3. Means you have to find three currents, I1, I2 and I3. And to find three variables, we need three equations. Means we have to consider three loops. We have to consider three loops. Okay, chalo, first loop we will consider. Okay, take loop. First of all, we are taking this loop. See, starting from A, B, C, A. First of all, this loop A, B, C, A. Take loop A, B, C, A, B, C. Okay, so starting from point A. So what you have to write? Yes, it is B. Okay, we are moving in this direction towards B. Okay, first we encountered 4 ohm resistor. Current flowing from is I2. We are moving from A to B, means we are moving in the direction of current, And you know that when we move in direction of current, potential drops, means we have to write minus sign. So yes, it is minus 4 I2. It is minus 4 I2. Clear about this? 4 into I2 minus 4 I2. Then yes, this resistance. Now we are moving from B to C. This resistance 2 ohm. Current flowing from is I2 plus I3. Again, we are moving in this direction, means in direction of current. Then how to write this? Minus 2 I2 plus I3. Minus 2 I2 plus I3. Then yes, this resistance from C to A. Resistance is 1 ohm. Current is I1. We are moving in direction of current, so it is minus 1. Here it is I1. Clear about this? Then yes, it is cell of EMF 10 volt. We are moving from negative terminal to positive terminal. Then we have to consider EMF as positive. Then yes, it is plus 10. And now we are again at point A. So yes, it is equal to VA. Clear about this? So yes, it is first loop. It is first loop. VA. Now we will check. Minus 4 I2. Minus 2 I2 plus I3 minus I1 and negative terminal to positive terminal, so you have to consider plus 10. Clear about this? Okay, so this VA current. Okay, now if you simplify this, minus 4 I2 minus 2 I2 minus 2 I3 minus I1, okay, plus 10 is equal to 0. Is equal to 0. I1, yes, here it is minus I1. I2, two terms having I2. Okay, if I take this each and every term on opposite side, they will become positive. So first of all, I will write I1. Yes, here it is I1. 4 I2, 2 I2 means it is plus 6 I2. Then it is I3. It is plus 2 I3 is equal to, here it is 10. Equation number 1. Clear about this? Clear about this? I1, yes. 4, 2 is 6 and it is 2 I3 is equal to 10. Equation number 1. Now you have to take another loop. Take loop. Chalo, which loop? Yes. A, B, C, D. Okay, now we will take loop A, B, C, A. A, B, C, A. Okay, so take loop A, B, C. Take loop A, B, C. See, first of all, we are starting from point A. So here it is V. Here it is V. 4 ohm resistance. Current I1 minus I2. We are moving in direction. So yes, we have to write minus 4 I1 minus I2. Clear about this? Okay. Then yes, this resistance 2 ohm. Current flowing from I2 plus I3 minus I1. And now see in this case, we are moving from D to C. In this direction, we are moving in opposite direction of current, means we have to write plus. So it is plus 2. Here it is I2 plus I3 minus I1. Okay, then C to A. See, C to A is common from first circuit. Okay, so yes, you can write directly if you can understand. It is 1 ohm. Current is I1. In direction means it is 1 I1. Then it is cell, negative terminal to positive terminal, 10 volt, then it is plus 10 is equal to V. Clear about this? Okay, now simplify it. See, VA cut. Okay, minus 4i1. Minus minus will become plus 4i2 plus 2i2 plus 2i3 minus 2i1 minus i1 plus 10 is equal to 0. Is equal to 0. Okay, now terms having i1, it is 4i1, it is 2i1 and it is i1. Means you will have minus 4, minus 2 is minus 6 and it is minus 7. So minus 7i1, minus 7i1. Terms having i2, it is 4i2, it is 2i2. Yes, only two terms. So 4i2 plus 2i2, it will become plus 6i2. Okay, terms having i3, terms having only one term, and yes, it is plus 2i3 and plus 10 is equal to 0. Plus 10 is equal to 0. Clear about this? Yes, you can also write this equation as 7i1 minus 6i2 minus 2i3 is equal to 10. Equation number 2. Equation number 2. Clear about this? Clear about this? Okay, now yes, we know that we need minimum 3 equations to find I1, I2 and I3. But if you observe these two equations, see, I1 plus 6I2 plus 2I3 is equal to 10. 7I1 minus 6I2 minus 2I3 is equal to 10. From these two equations, first of all, we will get value of I1. Because if you add these two equations, 6i2 minus 6i2, 2i3 minus 2i3, you will cancel out. And yes, you will get value of I1. But when you will find I2 and I3, okay, each and every term will be cancelled. Okay, so yes, how to find this? See, what we will do, we have to consider another loop, that take loop. Which loop we will consider? Yes, we will consider shortest loop. And which one is shortest? A, B, C, D, done. A, B, C, A, done. The shortest route is, yes, this one. Having only 2 resistance and 1 cell. Okay, so yes, we are taking this loop. See, we are starting from point B. B, C, D, E, B. Take loop B, C, D, E, B. Yes, starting from point B. So here it is VB. Starting from point B, VB. First resistance 2 ohm, current I2 plus I3. So in direction, we are moving in direction. So it is minus 2 I2 plus I3. Minus 2 I2 plus I3. Then this resistance 2 ohm, current is I2 plus I3 minus I1. We are moving in same direction. So minus 2. Yes, what is I2 plus I3 minus I3? I2 plus I3 minus I1. Clear about this? Then set of EMF 5 volt, negative terminal to positive terminal means plus 5 is equal to, we are again at point B. So here it is B. Clear about this? VB cut. Now how to simplify this? Minus 2y2 minus 2y3 minus 2y2 minus 2y3 minus will become plus 2y1 plus 5 is equal to 0. Clear about this? Okay, now terms having I1, yes, that is only one term. That is 2I1. Yes, it is 2I1. Terms having I2. Yes, it is 2I2. Then yes, it is 2I2. Then yes, only two terms means minus 2I2 means minus 4I2. Okay? Yes, okay. Then I3 minus 2I3 means it is minus 4I3 plus 5 is equal to 0. Plus 5 is equal to 0. Clear about this? Okay. So yes, you can also write this equation as 2I1 minus 4I2 minus 4I3 is equal to minus 5. Equation number 3. Now from my side, physics is over. Now it's all about maths. Yes, you have 3 equations. Equation number 1 having I1, I2, I3. Equation number 2 again having I1, I2 and I3. And equation number 3 having I1, I2 and I3. And now with the help of these three equations you have to find I1, I2 and I3. I1, I2 and I3. Okay. So yes, what is figure? How to apply Kirchhoff's law? You will get three equations and now you have to solve these three equations as your homework. Okay, what are answers of I1, I2 and I3? Yes, now you have to find only I1, I2 and I3. And one equation you can easily find what of I1. If you add equation number 1 and 2, you will get directly what is value of I1. Then if you get value of I1, it is easy to find I2 and I3. In this equation, put value of I1, you will get another two equations. Multiply, divide, you will get value of I2 and I3. Clear about this? So, important in this question is what is current distribution and how to take a look and how to solve that. Yes, you have to take care. You have to take care. Okay, when you write Kirchhoff's law. Because if there is only one mistake in any term, it is very difficult to identify your mistake. It is very difficult to identify your mistake. Okay, so yes, I1, I2 and I3 you have to find as your homework. Okay. Now another example, example 3.8. Yes, from figure you can say, sir, it is Western Bridge. Yes, it is Western Bridge. And what is your question? Your question is you have to find current flowing from this galvanometer. Now you may ask, sir, current flowing from this galvanometer it becomes zero. No, students. It is Western Bridge, not in balance condition. Why not in balance condition? See, it is R1, R2, R3 and R4. Is R1 upon R2 is equal to R3 upon R4? No. Here R1 upon R2 is not equal to R3 upon R4. Means Western Bridge is not in balance condition. So yes, first statement here you have to write. Here Western Bridge. Here Western Bridge is not in balanced condition. Is not in balanced condition. Clear about this? Okay. Then if it is not in balanced condition, then yes, current will flow from this galvanometer. And how to find current? So yes, to apply Kirchhoff's law, again we have to assume current distribution. Yes, you are given one cell of EMF 10 volt. I am assuming current flowing from positive terminal of cell is I. Current I. Yes, current I. At junction A, current I enters. And then see, it divides into branches. It divides into branches. So yes, here I am assuming in this branch current flowing is I1. And in this branch current flowing is I2. In this branch current flowing is I2. Clear about this? Okay, okay. Now how to find? See, you can write this I2 or you can also write this as I minus I1. It will be same. This side here is I1, this side here is I minus I1. Clear about this? Okay. Now I1. This point, from this point, again current divides into branches. Current divides into branches. I am assuming the current flowing from this galvanometer is Ig. Current flowing from this galvanometer is Ig. Then what is current flowing from this branch? What is current flowing from this branch? According to Kirchhoff's first rule, it is I1 minus Ig. It is I1 minus Ig. Clear about this? Clear about this? Okay. So yes, I1 from this point junction B, I1 this side, and here it is I1 minus Ig. What happens at point D? From this, it is I minus I1 enters. From this branch, Ig enters. So what is total current leaving this side? Addition of these two. Means it is I plus Ig minus I1. I plus Ig minus I1. Clear about this? Okay, now at point C, from this branch I1 minus Ig current enters. From this branch I plus Ig minus I1 enters. Now if we add them, see, if we add them, I1 positive, I1 negative, cancel. Ig positive, Ig negative, cancel. What remains? Only I. What remains? Only I. Yes, see, your current distribution is right. Because we have assumed the current flowing from positive terminal of cell is I. After this whole distribution of current entering this negative terminal is also I. Means you are right. Means you are right. Okay. So yes, how to write? Yes, we have to write one statement. Current distribution is as shown in figure. Current distribution is as shown in figure. Now again, yes, you have to find Ig. But you have three variables total current, I1 and Ig. Means you have to take three loops. You have to take three loops. Okay. So yes, now we will start how to take loop. Take loop. First loop, that it is BDAC. BDAB. Okay, this one, this half. So yes, if we take this loop, B, D, A, B. Okay, chalo. Starting from point B. So yes, here it is VB. Then galvanometer, its resistance is 15. Current is flowing in this direction. Means we are moving in direction of current. Then yes, it is minus 15 Ig. Clear about this? Then from D to A, resistance 60 ohm. Current I minus I1. We are moving in opposite direction. So yes, we have to write plus 60. Here it is I minus I1. Clear about this? Okay. Then we are moving from A to B. Resistance 100 ohm. Current I1, and we are moving in direction. So yes, it is minus 100 I1. Again at point B. So here it is VB cut. Now simplify this. See, minus 15 Ig plus 60 I minus 60 I1 minus 100 I1 is equal to 0. Clear about this? Okay. Yes, terms having I only one. So yes, it is 60 I. Terms having I1 minus 60I and minus 100I means yes, we have minus 160 I1. Terms having Ig means it is minus 15 Ig. Okay, and yes, is equal to, it is 0. Equation number 1. Clear about this? Okay. Now you have to take a look. See, take loop. First, we consider this loop BDAB. Now we will consider this loop BDCB. Another half BDC. Chalo, starting from point B. So yes, it is VB. Galvanometer, resistance 15 ohm. Current Ig in direction. So yes, it is minus 15 Ig. Clear about this? Okay. Next one is, yes, B to D. Then we are moving from D to C. What is resistance? 5 ohm. Current is I plus Ig minus I1. And yes, we are moving in direction. So yes, it is minus 5. Here it is I plus Ig minus I1. Okay. Then we are moving from C to B. Resistance 10. Current I1 minus Ig. And now we are moving in opposite direction. So it is plus. It is 10 I1 minus Ig is equal to, we are again at point B. So yes, it is VB cut. So minus 15 Ig minus 5I it is minus 5 Ig. Minus plus 5 I1. Here it is plus 10 I1 and minus 10 Ig is equal to, yes, here it is 0. Now simplify. First term having I minus 5I. Yes, only one term. Okay, so yes, it is minus 5I. Then terms having I1. Yes, here it is I1. Yes, here it is I1. Yes or no? Only two terms. 5I1 plus 10I1 means it is 15I1. It is 15I1. Clear about this? Okay. Next one is terms having IG. Minus 15IG, minus 5IG, and minus 10IG. Minus 15IG minus 5IG means minus 20IG, and minus 10IG means it is minus 30IG is equal to 0. Equation number. Clear about this? Okay. So yes, we have two equation. Equation first, equation number second. Equation number second. Now we have three variables I1, Ig, I1 and Ig. We know that maths says that to solve three variables we need minimum three equations. Okay. So how to obtain third equation? See, we will take this part. A, B, C, E, A. Take a look. A, B, C, E, A. A, B, C. We are starting from point A. So yes, here is B. We are moving towards B. I1, 100 ohm in direction. Means it is minus 100 I1. Then B to C in this direction. 10 ohm. I1 minus I2 in direction. Then it is minus 10 I1 minus IG. Then C2 cell of EMF 10 volt, negative terminal to positive terminal means it is plus 10. Then again at point A, that is equal to it is B. Clear about this? Okay, so this B A cut. What are remaining terms? Yes, here it is. Minus 100 I1 minus 10 I1 minus plus 10 IG. Minus plus 10 IG is equal to plus 10 is equal to 6. Okay, so terms having I1 it is minus 110 I1 and it is plus 10 IG is equal to minus 10. Equation number. Clear about this? Okay, so yes, now you have three equations. Equation number 1, equation number 2 and equation number 3. With the help of these three equations, you have to find value of I1 and Ig. Yes, physics is over. Now it is your homework. With the help of these three equations, do multiplications, divisions, addition, subtraction, and you have to find value of I1 and Ig. Okay, right now.